So we're going to put those together now to build up a new cycle. So we're going to use lattice enthalpy, solution, and also hydration. So if I put up the lattice enthalpy, so delta H lattice, so we're going to use sodium chloride, that would be Na plus gas plus Cl minus gas to give me NaCl solid. We've also got delta H hydration, and we've got two of those. Na plus gas plus aqueous goes to Na plus aqueous, and Cl minus gas plus aqueous goes to Cl minus aqueous. And we also have delta H solution, and again for sodium chloride, that's NaCl solid plus aqueous goes to NaCl, Na plus aqueous plus Cl minus aqueous because it splits up. So we're going to use those four to build up a cycle. So here we go. We're going to have a line there. Let's have a line there to start ourselves off. It's not going to be a huge one.
What else is annoying?
What?
In the summary sheet, you didn't bracket one of the aqueous.
Oh, that's really annoying. Sorry.
No problem.
Right, so bottom line is NaCl solid. Top line is Na plus gas plus Cl minus gas. So let's start with this side. What will this line represent? Let's go through here. Which one?
No, you've
That is
done it already wrong way.
Na plus as a gas goes to NaCl. So this is delta H lattice for NaCl.
In the summary sheet, the arrow goes the opposite way.
Doesn't matter. I'm doing it my way. I'm mixing things up. Making it exciting.
Are we putting anything else
It's not
above it or
exciting,
below it?
it's
No, that is it. That is it. Okay, I'm now going to go down this side. So I need to get from here to here using these ones. So the first one I'm going to use is I am going to use delta H hydration of Na plus gas. So that's just hydrating this guy. So I'm going to end up on this line it being Na plus aqueous. I've done absolutely nothing to chlorine yet, so that's still Cl minus gas. So I now need to deal with my chloride. So go down again. This is delta H hydration of Cl minus aqueous. That is going to give me Na plus aqueous and also Cl minus aqueous. So.
Okay, so you've made Na aqueous, then made Cl aqueous.
Yeah, so now I've got it. So this final line here is Na plus solid plus aqueous to give me my aqueous ion. So this line, my arrows going up, is delta H solution. Now, although it doesn't look it, this value is always low, but it can be either positive or negative. So there are two different ways of doing it. So we need to consider that now. So we've got, this is lattice enthalpy, then we have our two hydration energies of sodium and chloride, iod, and then delta H solution for sodium chloride. And we're going to try and relate these into an equation. Now, when we did Hess cycle last year, do you remember we did the circle? Now, if you like the circle, do the circle. If you don't like the circle, just learn it. Can you see, first of all, that these two arrows are going in the same way as my circle? Yeah. So, I'm going to build up an equation. So I'm going to say delta H hydration. I'm going to shorten hydration to just HYD of Na plus delta H hydration of Cl minus, because those two arrows go in the same way as my circle. Follow that arrow, follow that arrow, equals, these two arrows are going the opposite way. If I carry on going around, I follow that arrow, oh, that arrow's going the wrong way, and that arrow's going the wrong way. They equal the other two, so they equal delta H solution plus delta H lattice. And you can use this equation, if you know the other three, you can use it to work out the one missing one in a similar way that we did the Hess cycle last year. Okay, so this value here, this value is very, very big and negative. So this is a large exothermic value. Now also, both of these are large and exothermic. So, where the delta H solution, I've made this large because I want to demonstrate it, but this value here can be endothermic or exothermic. I've shown it here as being what? Endothermic. However, that is because this way I have shown it as being endothermic, so I'll get rid of that here. So that would suggest that this value, this large exothermic value, is more exothermic than these two, because I want to go endothermic. So this one here, so for this one we can say delta H lattice in this example is more exothermic, so therefore more negative than delta H hydration for Na plus gas and Cl minus gas. If you're just joining us, this is I'll change that into a gas state. Right, so that would be the case for this one. However, it's not always the case. Sometimes these two values will be more exothermic. So if that's the case, however, sometimes delta H hydration values are more exothermic than delta H lattice. This means delta H solution is exothermic. So I've shown this as being endothermic, but if these are bigger, more exothermic, it pushes it down. So do you want me to redraw that? So if that would be the case, I'll just draw it.
So if this is endothermic, delta H lattice is more negative. If it's exothermic, the Na and the Cl is more.
That's right, yeah. Okay. So what I'm saying is, if I change this, say I do delta H hydration for Na plus gas goes to there, so that gives me Na plus aqueous plus Cl minus gas. Then I hydrate chlorine, so that's delta H hydration for Cl minus gas. So that now gives me the line down here as being Na plus aqueous plus Cl minus aqueous. It means to get back up to here, Na plus aqueous, sorry, to go now to dissolve, my Na, my sodium chloride solid is going down, so now this is going to be exothermic, because these are more negative than this side, so that means it's become exothermic.
Wait, so your end product wouldn't be the NaCl?
Well, it doesn't, I mean, you don't really have an end product in a way, because this is just a cycle. It depends, okay. What I'm saying is this is pushing it down, so this now, what I'm basically, my bottom line is that now NaCl solid. The lowest energy state is actually this one here, and it's pushed it below my NaCl solid. So it goes underneath it, so it's now so you need to consider, we're going to now look at factors which will affect this, delta H lattice, and also delta H hydration. But the key thing is, this value is sometimes either plus 5 kilojoules per mole or minus 5 kilojoules. It's always a tiny value. It hovers around 0. And you know that when you dissolve things, you don't get major energy changes, do you? If you dissolve salt in water, it doesn't suddenly get hot or cold. It just kind of like, it's the same. They're normally small. We look at why dissolve, it happens in our next topic. But these values you would know were happening. These are big, big negative values. But it's a competition between the two as to what will affect that one there. Is that all right?
No.